Dear children, let us understand what is the significance of negative sign in energy expression. If you consider Bohr's atomic model, this is the energy expression for a given stationary state. That is, En is equal to minus 2.18 into 10 power minus 18 z square by n square, that is joules, joules per atom, joules per atom. Now, in this expression, there is a negative sign. So, for energy, we are having a negative sign. So what does it mean, or what's the significance of that? Let us understand. Now, there's a common rule that if you consider stability of any atom, electron, or anything, the one which is at lower energy state is always a stable one. For example, if you are very happy or very sad, definitely you are unstable. So now, either by crying or either by laughing, definitely will come back to normal, right? Same way, if you consider electron in the lowest energy state is always always stable. Now, what's the significance? Let us understand now. So this is the energy expression. So according to Bohr's, so we know that there is a nucleus and electron revolving in the definite orbits. Each orbits will have certain energy. Now, using this energy expression, I have calculated the energy of three orbits, E1, E2 and E3. And the number of orbits in a given atom extend up to what? Infinity. E infinity will be 0. If I substitute n is equal to infinity, 1 by infinity will be 0. Now, for all n values, we are going to get a negative answer for a given energy for stationary state. For all n values, energy value will be negative. If I substitute energy n is equal to infinity, there we get E is equal to 0, energy is equal to 0. To understand the significance, let us take an electron. Where the electron is, now the electron is here, the first orbit. You consider this electron and the other electron is at infinite state. When I say infinite state, the one which is nearer to the nucleus, the electron that is nearer to the nucleus, are more attracted towards the nucleus. Therefore, when it is nearer to the nucleus, the attractive force between nucleus and the electron is stronger. That means nucleus has a control on electron. Suppose you take an electron at infinite distance. When I say infinite distance, the nucleus has no control on the electron. Therefore, if you consider the electron which is in the first orbit and the electron which is in the infinite state, definitely this is said to be stable. The one which is nearer to the nucleus is said to be stable. Now, how do we say that? The justification is given by looking at the energy value. So, the one which is nearer to the nucleus, that is E1, has minus 2.18 into 10 power minus 18. That's a negative value. The one which is at infinity, when I say infinity, this is known as free electron. Free electron. When I say free electron, it is not under the influence of the nucleus. So, which is stable? For this infinite state, energy of the electron is said to be 0. So, here there is a positive value and there is a negative value. Definitely, this will have a lower energy, due to which the one which is nearer to the nucleus is always stable compared to the electron which is in the free state. What do you mean by free state? Free state means the electron which is far away from the nucleus. Far away from the nucleus. And we say that when the electron gains energy, it moves from lower stationary state to higher stationary state. Now, how do we justify that? Look at the energy value. As the number increases, the orbit number increases, the energy value becomes less negative, right? Less negative. When I say less negative and more negative, which is more energy? Definitely less negative will be the more energy. So compared to E1, E2 and E3, which will have more energy? Definitely E3. Why E3? The value is less negative. Therefore, as we move away from the nucleus, Definitely, energy of the orbits increases. Energy of the orbits increases. And wherever the electron having the lowest energy state, that state we call it as ground state. This ground state is said to be stable for any electron. Thank you.